Hi there everybody, welcome to another math school video. Today we're going to be looking at two maths tricks which are going to help you divide by big numbers. Alright, if you haven't done already, please make sure that you subscribe to the YouTube channel. This is the only place you're going to come across these little maths tricks. I'm not going to post these on our website, so please make sure that you have subscribed to the channel so that you don't miss out on this and a number of other tips and tricks and problem solving types of questions coming down the line. Alright, so first trick, treat it like a fraction. What I mean by that is essentially when you are looking at division, the idea of dividing by a big number is sometimes quite daunting. Most students are happy to go up to 10, maybe 11 or 12, but because their times tables don't go beyond there, when the number gets bigger than that, they find it a bit more of a challenge and not quite sure what approach to take. Alright, so fractions is a way of supporting them in doing that. So let's look at an example. So if I said to you 1296 divided by 24, again, divided by 24 is way beyond most students' remit in terms of the times table skills. So what students potentially do, they might decide to chunk it, they might decide to go to 24 times 10, and so on and so on and so on. And that's going to take a period of time. So what I'm suggesting is you write it like a fraction. So you write it as 1296 over 24, because that line in between the two numbers is essentially divide. But if I had a fraction looking like this, 1200 divided by 24, it would almost certainly be in an exam paper that would ask you then to simplify it. So why don't we do exactly that? Because if I simplified it, it's not changing the question, it's making an equivalent fraction, which essentially means it's an equivalent question. It's just going to make the numbers much easier. So looking at those two numbers, I can see that they're both even, and that's really important because actually it's going to determine how we're going to cancel it down, how we're going to simplify it, because I'm basically going to start by dividing top and bottom by 2, halving them. Okay, so when I divide top and bottom by 2, I get 648 over 12, and already the calculation is easier, but of course they're still even, so do it again. So 648 divided by 12 becomes 324 divided by 6, but of course they're still even. So one more time, that leaves me the 162 divided by 3. So 162 over 3 is equivalent, so 1296 divided by 24. So most students would be comfortable using a bus stop method potentially to work out that division. It's certainly an awful lot easier. Alright, so I'm going to finish it off using the bus stop methods. So how many 3's going to 1? None. With 1 left, so carry that over. So how many 3's going to 16? Well, there's 5 with 1 left over. And how many 3's going to 12? 4. So my solution is going to be 54. Alright, so 1296 divided by 24, my question is 54. Just by using fractions makes the calculation much easier to deal with. Alright, so that's the first trick. Trick number 2 is about prime factorisation. Alright, so to make it consistent, I'm going to use the same example, but I'll show you a different approach. Alright, so depending on the question is really going to determine how you approach these. Okay, so this particular one, same question, I'm going to use prime factors. Alright, so if you're not familiar with prime factor trees or the product of prime factors, then it's probably worth noting that and probably getting onto some of the other videos that are out there that I have on the website or on the channel. If you're subscribed, it'll be one of those on there. But essentially I'm going to break it down into its prime factors. A couple of ways you can do that. Prime factor tree is probably the most common one that most people will have learnt, but of course there is a button on the calculator that does it for you, but this is more likely to be a non-calculator paper. Alright, so let's look at the prime factor tree. So 1296 is a bit of a beast, which looks like this, and 24 is a little bit better, which looks like this. And then it's the numbers in the red circles, which essentially are our prime factors, and they're going to form our product of prime factors. Okay, so 1296 can be written as a product of prime factors, all right, like this: 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. All right, 24 can be written as 2 times 2 times 2 times 3. All right, I'm not going to do the top one, but certainly 2 times 2 is 4, times 2 is 8, times 3 is 24. All right, so they're both written as products of prime numbers, essentially prime factors. It's at this point then I look to what I call cancel out. Right, so whatever I've got in the top one, 1296, if I've got the same in the bottom one, they're essentially going to cancel each other out, because remember, I'm doing 1 divided by the other, and if I said 2 divided by 2, it's going to be 1, and essentially 1 times something is the same thing. So what happens is I cancel the 2 2's out, because there's 1 in the top and the bottom. And I'm going to do the same for the next couple, because they're both the same. And then again, I've got another 2 and another 2. So far, I've basically cancelled whatever's in the top, the same in the bottom. I've now got 3, so I need to cancel the 3 in the top and the bottom. And there's nothing left in the bottom anymore. There's nothing else I can cancel here. All right, there's nothing else I can do. So I now have to deal with whatever is left. Well, all I'm left with is essentially the 2, the 3, the 3, and the 3. So that must be my solution. 2 times 3 times 3 times 3 is 54. All right, 2 times 3 is 6, times by 3 is 18, times by 3 is 54. And of course you can do it now, it doesn't matter which way around you do it, but that is my answer, as you knew from the previous ones. All right, so this is now about prime factorisation. Now this one, again, this is probably a little bit more long-winded because of the process of a prime factor tree, but actually this is quite useful knowing this, because it works well with algebra as well. All right, when you're looking to divide algebra something like that, because you've got an x in the top, you can have an x in the bottom. Again, that cancelling out idea works really, really, really well. All right, so 2 tricks I just thought you would find useful anyway, to kind of look at how to divide bigger numbers. All right, you decide. Different approaches. All right, just a little bit easier than the bus stop method, or trying to do your 24 times table, I thought. Okay, so if you haven't already, again, I've mentioned it one last time, please do make sure that you have subscribed. All right, I'm going to be posting loads more information about problem solving questions, tips and tricks, all those kind of different things on the YouTube channel only. So please make sure you have subscribed, so you don't miss out on some of those. All right, but thanks very much for listening. All right.